Hi, Karunya. Good evening.
Good evening, sir.
Good. So, how are you doing? It's a long time. I think we had a session recently, correct?
Yes, more than 4 days, I guess.
Yeah. Sure. Hi, Padender. How are you? Okay. Looks like Padender has a voice issue. So, I think we can get started. Hi, Padender. How are you? Okay. So, who is providing the presentation? You, Karunya or Padender? Who is doing it? The first session of deep learning. Who is doing it? Nobody is. Both are tightly.
Sir, I can give actually a recap, sir.
Yeah. Okay. Go ahead.
So what is deep learning is like we've learned that deep learning is like subset of machine learning that usually uses neural networks with multiple layers. So neural networks are usually like how it actually works in human brain. It's just like that. And what are the applications of deep learning is like image recognition in NLP, speech recognition, and there are more we can use. And we learned about PyTorch basics and tensors also. So PyTorch is like an open source for deep learning. It is developed by Facebook, I guess. So tensors are like multi-dimensional arrays. So they are similar to NumPy arrays. Yeah, and we've learned about autograd also. Like automatically, it computes gradients for back propagation. And we also saw a few examples like for building neural networks. Uh, so yeah, and then I guess that's what I remember, sir. We saw a few programs. Then I guess network was lost.
I see. Okay. Okay. So what we do is, okay. So now I think this is what actually you have been waiting for some time. I was waiting for some time to share it, with you, which is this. Let me share my screen. Okay, guys. So this is the new website. So what we are trying, what what is this all about? So first of all, you have the option to take the presentation, which is actually you already have this. So this will be, you know, this area you're already using it. Same thing will be here. Okay. And then you also have okay, so and there is one more thing. You can actually join the Discord link directly here, and then you have the pre-read. So then once it is completed, you know, you can also do that, and then there is a join session. So directly, you know, you can actually join the session directly here, so that you don't have to, I don't have to send the URL. So you will come to know about this. And I will also share the recording once it is available, so that, you know, you can actually access that. Okay. And next, I mean, this recording may not be there all the time, but at least, you know, it should be available most of the time. And it will be there for some time, so that, you know, if you have missed by any chance, you know, it will be available, and you can start the test, and I can give you assignments. I will show you next time. And the next is, then you have the pre-read. So pre-read is all about this. So here you have the what we will be learning, and you know, it is, you have to read before this, so that, you know, you will get a clarity on what I am rebuilding. So then to do this, what you need to do is, I will actually send you the this. So please join this. So once you register, I will be able to grant you the access. Okay. So please do that. So from now onwards, you will be okay. So I will also add more things, like, you know, yeah, more details actually you will come to know later. So there are like, you know, code walkthroughs and all is there, so that it will be easy for you to you know, go through. For example, if you want to prepare any DSA, data structures and algorithms, so how this will work. For example, here it is. Here, this particular thing is actually bubble sort. The bubble sort, you know, what it does. So, you know, this is the program in the for the bubble sort. Then how that really works, actually, that is given. So now, if you, for example, if there is a list and there is a variable, you know, what you can do here is, see, you will have the 64, 12, 34, and 25. And when you actually, when you step by step, you will know what is happening. So then, you know, each value, each variable, you know, the value you can see that. So this, by this, you know, I mean, I'm going to add even others also. Right now, I have added only quick sort and bubble sort, and I will be adding all the sorting algorithms, so that you will come to know, you know, what does each thing do, so that, you know, you will be able to understand how some things are done, and you will know more visually, and more importantly, how the internally, how that is going to change and all, it is going to happen. And like, you know, for example, dictionary. So dictionary, how it works. So you can actually, dictionary view you can add, and actually know how each thing actually will do. So you will be able to review in just 2-3 minutes. You will be able to review everything, and all the features of dictionary I would have added, and actually both beginners and advanced, it will be there. Okay. And one more thing is, I will be adding one more next week. I will actually get you, before you finish this deep learning, you will also do, like, you will get a step by step, you know, step by step, you will get the you know, instructions on what to do, what is the technology, and what is the design. And so that, you know, when you do a project, you should be able to explain it to others as well, and you should be able to use that. Okay. So that is what actually I'm building, so that all these things should be able to, you know, you should be able to understand the code more closer, and more easier, and more detailed. Okay. All that requires is your attention, and when you pay your attention, you will be able to understand, more clearly than actually, guessing what might be happening. So here, this code. So for example, quick sort, how that actually works. So you will be able to see in action. So the program, you will see the program here. And the when you give the values, how that exactly done, and how many steps are taken, and when this is called, and all these things will come alive. So as if you are going through each step and getting the values, how the values are getting changed in every step. So this should give you, the more detailed understanding, and that should help your perception. So today what I will do is, I have given you the URL. Please register. Okay. So once you register, so I will actually grant you the access, and you will do that. So you will also have the tests also. So you will be able to get understanding where you are good, and what is happening, and all the Viva questions, everything will be here. So it is like a one place where you will get all the details. Good. So hope you are actually hope you like this. So first register, and we'll see. Good. So now we will get to the session. So when you register to this, so you will actually get uh, the what guest modes initially, and once the guest mode is once I assign it to you, one batch, you will be able to get all the batch related things, including tests and everything. Okay, so thanks for actually staying with me, keeping calm, because we almost missed 3 sessions so far. So we will try to cover that as soon as possible. Starting today, we will try to cover the other classes also, and we will plan to complete deep learning by next week, mid next week. So please, if not mid next week, by next week we should be able to complete deep learning also. And as I mentioned earlier, you should be doing the projects. So I will be giving the projects in this one only, so that you'll feel like more guided. Okay, good. So okay, that's it. And yeah, Aishwarya, I see you joined. Do you have any presentations to give?
Hi, sir. Like I'm not prepared for presentation as such for
Okay.
today's session.
Fine. So make sure you're actually presenting it, because it is long pending thing from your side. I think you are. I know that you're trying to catch up, but yeah, do it soon.
Yes, sir.
Okay. Okay. So all three of you, you can actually register for this. Then we can get started with the session today.
Sir, I did, sir.
Okay. So I see 32. Yes, you registered. Okay, I will do that, and from tomorrow you will be able to access, I guess. Then, okay, so then actually we will start now. So here, okay, guys. So now you are in deep learning, right? So deep learning is, what? So the earlier session, I guess, is this session 1 launch. So this is the first session. The first session, I guess, you already we have gone through it. Okay, guys, one more thing, guys. See, the level of, we are not going very deep during our sessions, but why we are doing that is done on a purpose. Because see, if I try to explain about complete machine learning and use all the jargons, probably you may not understand completely. That is why we are going slowly, but definitely you will understand. Why? Because I can actually cover a lot in one day, but that is not the my intention. My intention is that you need to understand every concept more clearly. When you get it, when you get things more clearly, then you will be able to do the programming. The problem is most of the people, what they do is they will try to get the difficult concept, difficult concepts very easily, which will not happen. But that's very difficult. So all I'm saying is, guys, if you are understanding this, it is great. But know that whatever I'm teaching you are the basics. So that will set you up. For example, machine learning, whatever I taught you, so that is good basics for AI engineer. It is actually good, but from the interview perspective, you need to prepare a lot. So that is why, in the questions, in the test, you will have questions which might be little tough. And sometimes, few things are not very, there may be few questions that, you may not have come across. You need to do some research, or you can actually send the request for additional, trainings or, some help. I can do that. So the thing is, try to do that, research yourself, or feel free to ask for help. I am happy to provide that as well. Okay. So the only thing is, you need to complete all the tests. Only thing is you need to do is you need to complete all the tests, and you get 100%, and you can clear any interview question just like this, because you have a very strong foundational knowledge on the that machine learning, deep learning, and AI, LLM, the complete then complete full stack you will be able to understand. So when you have complete clarity on the fundamentals, and then you work on the interview preparation, then that will be a killer combination. So you are not getting overwhelmed with the lot of concepts, but at the same time you will also prepare on the interview questions, because once you are clear with basics or fundamental concepts, it is not very difficult for you to understand the advanced concepts. So that is why, if you come across some of the difficult questions on, say, for example, machine learning, and you may feel that, I didn't go through this, so that is natural. But all that will be covered in two things. One is the tests, and one more is projects. So projects will be tough, and you need to work on it. So I will give you two sets of projects. One you can do easily, and other one that is thorough. So you work on both, and you should be able to finish it. You should be able to complete, and you should be able to get the complete understanding of the subject. Okay, so the idea is, you get your, first of all, your mind should feel, or mind should get tricked that it is very easy. It is easy to understand. And once it is easy to understand, then you can actually go to any extent. So you can learn anything, because when the foundation is strong, you will be able to learn anything. Right? So just wanted to be sure about that. So that is why I told this. So now you have a lot of resources. I think you should make use of them. Okay, so now in the earlier session, in the first session, we discussed about what is deep learning, and we discussed, as Karina told, it is very much comparable to the neurons, our brain cells have layers. Now we have multiple neurons working together, and we have connections, and we have learning. Like, we will give more examples, and it will get better. So that is first thing. And actually, next is PyTorch. So PyTorch, PyTorch contains tensors. So they are multi-dimensional arrays. It can be single dimensional, it can be double, it can be three-dimensional array also. This is automatic differentiation grading. So it will calculate the gradients for you, right? It is like very much like a Lego kit, what you would have seen. Then next is, when you are building a simple neural network, so what we will do is this. See, you say layer 1 and layer 2. Layer 1, it will convert input into hidden. Hidden means, so there are two important things. One is input and output. So these two are important for every, neural network. So you need to have two layers at least, one input, one layer, so which will convert input into output. And then there is a hidden layers. That hidden layer, you will be having, many things. Okay, so one translates to other, and other translates to one more. Like this, you can have multiple layers. So we will see how that will actually work. So we will see that, and we have executed that, and you have seen the results. Now, finally we have understood the activation functions. So activation functions are very important. So you see that. See, first of all, there are four functions actually we have discussed. Guys, are you sure we have done this? Hello.
No, sir, no, sir. We just discussed about the neural network code example.
Oh, okay. So did we complete this? I thought we completed, right?
Yes, sir, yes, sir.
Okay. So, okay. And what about this? Did we complete this concept tree, building a simple network?
Yes, sir, yes, sir, yes, sir.
We did that, correct? Okay.
Yes, sir.
So, okay. Then, and we didn't complete this concept 4, correct?
Yes, sir.
Okay, fine. So now actually, okay, then actually we will do little bit of that, and then we will come here. So first of all, concept number 1, you know it very well. That is more of a theory. And now we will understand what is the PyTorch. PyTorch. So what is a PyTorch? So PyTorch is actually very important. See, now you know that this one. So deep learning. So what are the? I think yesterday also we discussed, right? So PyTorch alternate. So when you say PyTorch alternate, PyTorch is actually a pure deep learning framework. Now you have got TensorFlow. See, don't confuse with TensorFlow and Tensor. See, TensorFlow is actually developed by Google. Okay. They also called as tensors. So, and then JAX, then actually scikit-learn also provide some range of deep learning, and Keras. So Keras and actually TensorFlow, these are the most important. And now that is PyTorch. Actually recently they are into this area arena, and they are doing very well. So PyTorch actually generally used for you know what uh, uh, so basically, TensorFlow is actually more of a open source thing, and PyTorch they are used by the mid-size companies where where they want a earlier push. They want to get started immediately. So for them, it will be very nice. Okay, so they will be using this. So because they will get a head start. So then now we will come to Gen A. No, this concept number 2. So PyTorch. Okay. So this PyTorch is this. PyTorch is, it is like a this has a Python library. Okay. So as a name suggests, so these, there are a lot of libraries, so which will work in Python, and there are other variants also. So this PyTorch is actually written specifically for Python, and building neural network has been very easy with this. So now, first of all, how this is actually done is this. See, it is like they have tensors. Each tensor is like a smart Excel sheet. It's like an Excel sheet. It can have one value, it can have it can have one dimensional, or it can have multi-dimensional, or it can have three-dimensional also. So you can, and even you can have four-dimensional. So how it will be there? We will see that. Okay. So that is actually about PyTorch. Okay, now then actually autograd. So see, then you know what is a gradient, right? So how that gradient is there, and differentiation means when you have multiple values, how they are different. Okay. Uh, how they are different, actually it will be able to tell. Okay. And one more thing is, see, it is not like, see, this PyTorch is not something complex thing to learn. You do not think that it is actually very complex thing to learn, but it is just an enabler. Think like that. It is just an enabler. So here actually I was actually telling about this. So the dimension, there are 0, 1, 2, 3, 4, 5, like this it will be there. Now, zero tensor means what? One single value, right? And 1D means it is like a single array, and it is a array of arrays or matrix. And then 3D plus 3D, 4D, like that, it is there. For example, in 2D tensor, you can display something, and but actually for 3D tensors, you can have images, videos, some complex data, or time sensitive data, like that. So you can do all these things. So this is what actually is the tensors. Tensors is nothing but a simple value. That's it. Okay. So now you know that, okay, we already know that Tesla is using the PyTorch, self-driving car vision. For vision, they are using the PyTorch. So then you can understand. So this is much capable. It is very capable of doing. And then they're also using Disney and for animations and all those things. So good. So most of the AI papers, they use PyTorch. So that means it is very powerful and very popular. So the first tensor, let us actually create it. Okay, so now you might be wondering, what is a tensor? So let us actually look at this. So here we are importing the torch. Okay, we are importing the torch. We are running it. Okay, and then after we run, we create a tensor. So you say torch dot tensor, then you provide a array. It can be a single value or multiple array, or it can be even that it can be double dimensional or triple dimensional array. And when we print it, what happens? We will see. So you see that it says tensor, and it is 1, 2, 3, 4, 5. So this 1, 2, 3, 4, 5 is stored in tensor. So, but what you can do with tensor? So we will see that. So here, for example, let's say A is a tensor and B is a tensor. And when you combine, when you multiply, you see what happens. So you see 1 plus 4, 2 plus 5, like that it will be done. So you see that that's a tensor. And addition and multiplication also, you can do that. You see it is done. Okay. So this is how tensors work. Hope you understand. So this is very easy. Now you can ask me, by doing this, what happens? So that's what actually we're going to see in today and next session. And there are other things also, like shape and things like that. So the type, what is the type? It says it is a tensor. Okay, and shape and everything will be there. For example, so we have a matrix multiplication and things like that. So you can do all these things here, and you can say what is the shape of that. What is the shape of the one particular tensor? So I will say A dot shape. The torch size of 3. Suppose if you say seven, 8, 2, 3, 4. Okay, so you see that when you run the shape, it will give accordingly. It is actually B, sorry. So you see, accordingly, this will actually get changed. It is running 3, 3. So you understood, right? So hope it is clear. Then we will actually do. So you understand basic tensor operations. So hope you have understood. So I don't think it's a problem. Now we will go to the third concept, which is building a simple neural network. So when you say neural network, this is how it will be there. So neural network, you might have seen, and actually it can be seen like this. It will start from input. Okay, let's actually show me. Let me show this. So on the right side, you can see that these are the input layer and this is the output layer. Okay, sometimes it will be resulting in one single node. So you see, this is layer and this is another layer, this is another layer, right? So each layer can have multiple nodes and there will be multiple lines. So, and sometimes the path can be limited or it can go to any line. So why we have this? So you see that there is an input data. So you know that any problem you want to solve will have the numbers. And you know that computers are, especially the machine learning and deep learning, they will use only numbers. They cannot use anything other than numbers. So that means anything you do, whether words or understanding a text or something. For example, when you go to chat gpt and if you say, well, what is the capital city of Paris, only numbers will only numbers are numbers do the magic. So internally no computation is done with the words. So when you have only words here, how those words have to be modified or added or transformed, all these things are done in multiple layers. So earlier you have a machine learning. In the machine learning, it is like we are building a small node. But here we have multiple layers, and each layer we will be able to modify, add, transform, split, all these things you do. So that will actually get me some node with some numbers, and that numbers will tell me what exactly I need to do. So hope you understand. That is exactly the deep learning. Like this, you can build multiple nodes. Okay, so we are building one such a node here. So please pay attention here. So what we are doing is we are doing a very, very simplest implementation of the neural network. Okay, so whatever you see here, whatever you see here is a neural network. Okay, and you know that neural networks are very popular and very powerful. So we are building one such neural network here. So you know, but don't think why it is useful. We are building that small thing so that you grasp the concept. So now you see that you will stack the layers like a building blocks, right? So each layer will add flavor, different flavors. Like for example, when you prepare any dish, you will add one layer of something and you add another layer of something like that. Here also you will keep adding multiple layers so that you will understand. I mean, the numbers will get transformed, and finally you will get the result, the final result, whatever you want, you can. Okay. So then example is sandwich. You have, I think you might have. I mean, you might be liking sandwich as well. What you do, you put a piece of slice of bread and actually add a layer by layer. You add it. Finally, you cover it up with one more slice of bread, and then the two bread slices on each side is actually input and output, and everything else what goes inside actually will be that. So from the composition perspective, you can think that that is actually your neural network. Now we will see that we have seen that input layer, that is the like a sensors. So these are the data that is given to this. So data will be provided. And next you have a hidden layers. What is hidden layers? So this will do all the thinking. Okay. So there can be one layer or there can be multiple layers. Okay. And finally, when all these layers, so now all these layers should work in tandem. And finally, when all the layers finish, when they are done, the data will be reach the output layer, where that is actually the prediction. That is what the decision we want to take. And in between, so you need to see weights and biases. So this is very, so this will play very important role in the neural network. So this is what are learnable means. The the neural network learns over time. So I will tell you how it is. Based on how they learn, they will add weights and biases. That is what actually we are going to learn, and we are going to do it, right? So hope this has given you very good understanding of the neural network. So trust me on this, guys. You will really love the deep learning. So we will actually see that these are the various things you can actually try. Okay, and so first neural network we will build it. You see that what we are trying to do. We are this code is actually, I have already explained it, and this is very readable. You can actually read it very easily, right? And this is not actually very complex as this particular diagram shows, but this is very much readable, right? So you see, you create two layers. One layer connects input to hidden, and the other layer connects to hidden to output. As simple as that. Okay. So this actually gives the completely working model. It is complete working model. So here you see what exactly we have done. I will tell you. Okay. So you see that there are, like in it, we will provide, these are the sensors. You can think it is an input. We will provide input size, hidden size, and output size. So when we provide that, right? So we want to see the output layer. Okay. And you see that this is actually, okay, first of all, okay, I want to tell you about semantics. See, here is actually how you write the code in the neural network. First of all, it's a class. And you name the class, and this should actually inherit from nn.Module. Okay. From that module, it should inherit it. So you know that this is the init, and this is what actually will run. And you see that input size, hidden size, and output size. These are all the values you need to provide. And inside that, you will also have self.layer1, layer2, like that you will have. Okay. So how, when you declare lot of layers, don't think that, this is automatically done from layer 1 to layer 2, layer 3 to layer 4. No, they are not done. First of all, you actually, you layer 1 is equal to what? It is a linear, and you declare it as one type of neural network, neuron, and it will take the input size and hidden size. These two are layer 1, and layer 2, again linear. So that hidden size to output size, it is actually transforming. So these are all the two things which will take two parameters. And finally, we will say x is equal to self.layer2, and we will actually. So now we will see the complete code in action. So here is the complete code. You can see that. So I hope you understood the code, whatever this is given. So now here is the complete code. The complete code is this. Now you see that. So first of all, okay, so we will actually do one thing. Let us actually do one thing without the neural network. Then actually we will actually build one. Okay. So now you see that. See, nowhere we have used torch or this one. So all we have used this, and then actually we will do that. Okay. So first of all, we are giving the inputs as 1, 2, and there are some weights for this. So actually we will give 0.5 and 0.5. So now first of all, we will declare a numpy. So guys, actually all I'm using right now is not PyTorch. Okay. I will actually do that again. I will show you. Now you see that this is input features and weights. So now you see that the we have given two things here. One is the inputs. Inputs means that becomes the input for the program, and next is this part. Okay, this part is neural network. So this is one method, simple method. Okay, simple method which takes that inputs, weights, and bias, and finally we are running the neural network. So this whole thing, right? This whole thing will actually call this method, and it will do it. So now, see, this is not. You see that this is not actually neural network or something. Now, okay, we will actually run this and see. First of all, you know that we are creating the inputs and weights, and bias is equal to 0. Run this, and we are actually calculating the output here. So we are defining the method which will take this inputs, weights, and bias. And what it does is there is a method called np.dot. So np means numpy. Okay, dot. Can anyone tell me what is dot? Yes, anyone?
Is it like multiplications?
Yes. So what type of multiplication?
Like I didn't get you, sir. Like what type of
No,
means?
what this exactly does. So see, now you see the inputs is actually a array, and weights is again another one more array. So what kind of multiplication is that?
Like the first element of inputs will be multiplied with the first element of weights, and then the second element of input will be multiplied with second element of weight.
Perfect.
And then the
So
final array will get, and that will get added to bias.
Perfect. Then actually you add a bias to it and then output. Okay, then finally we added the sigmoid. So the sigmoid actually or it just means, the values closer to 0 become 0 and value closer to 1 becomes 1. So as simple as that. So probably you might have heard. So sigmoid function. See, this is very simple. You don't need to, you don't need to be a pro in mathematics. So it is like this. The values which are closer to 0, it goes to 0 and 1 goes to 1. So like that. So now what we do is here we ran this and we will run this and we're printing the result. Result is equal to 1. But if you don't convert, output is I want just 1 total input. I want output is equal to total input, whatever the value that is calculated, and we will run it. You see the value is 1.5. So that is actually truncated to 1. So how it is done? So 1.5 and 2, half of 2 is 1.5, and 1.5 it is actually truncated to 1. So the value, I mean, this will make sure, sigmoid will make sure that this is always, the value will be either 0 or 1. Any value above 1 is 1, any value below 0 is 0, like that. So hope you understand. So now we will come back to this. Okay. So if total input is greater than 0, it is 1, and any other value is 0, 1 or 0. So hope you understand. So now why this is used? So this is simplest implementation. Actually, we will see how this can be used. But this is what is one implementation. So I think you have understood simple value which is done, right? Now, how the whole thing can be done using the tensor. So that is what actually we will see that. Okay. So what we will do is we will actually run one more thing. You see that we will do import torch. So we will be able to use it. Then once we have imported, we will say inputs is equal to torch dot tensor bracket open. So we will copy exact same thing. Actually, we will copy entire thing. So what we will do, instead of np.array, we will say torch.tensor. Why I am doing this? I am going to show you this is very easy. And bias also, can we do this? Torch of tensor. So this is a single value. It is a 0 dimension. Means because it doesn't have any dimension, we have to say it is a 0 dimension. Now we have given inputs is equal to touch.tensor 1 comma 2 and 0.5 0.5 and all these things. And now we will actually say what? So we have to do okay, we will actually do what? So we can actually do two ways. So let us do one thing. Let's go step by step because you completely need to understand. Okay. So before you convert into neural network, so what we will do is we will actually convert into a simple, method only. Okay. So we have already seen this. We will create a class and which inherits from nn module. So we will do the same thing and we will do the init. Okay. You see that we are creating a class. So we will say simple network, and we will create the, okay, we have imported. So where is this imported? We will see that import torch.nn is as nm. So now we have got nn.Module in it. So then actually what we will do is, we will say init, okay. Def.init. So these inputs, input size, hidden size, we don't need it. All we need is self. Okay. Now what we will do is we will call it super, means its parent, means what, nn.Module.super. We will say this and this. So same thing. This class name we are giving simple network and self dot init. So we are calling the parent classes super method. Okay. So already you have used already this, and now we will go step by step. So we have got two things. One is we have got the inputs, we have got the weights, and we have got the bias. So inputs is different, weights and bias are different, because weights and bias are system driven. That is why we will give system, the system we will give. So self dot weights is equal to, we have to say as a parameter. Okay, thank God it is actually working. So now you say nn.parameter, we are passing as a parameter. This task dot tensor already it is defined here. It is defined. So weights, it's already defined. Okay. And same way, this tensor is also defined. So we will say bias. So this bias is defined, weights are defined, we have given it. So now we have got, this is done, init is complete now. Now what we are trying to do, we are trying to forward. This is important. So there, forward, when you forward, so you say cell and we have to give inputs. So when you say input, so the total output is equal to torch dot dot, because earlier implementation, guys, we have used dot, same thing we are using here. We are not discovering anything here, we are just saying torch dot dot x means that inputs and weights plus bias and return output. Okay, so we have done, this is the simplest neural network where the inputs are taken and you put it down and do it. And next is, we will say one new model is equal to simple network and result is equal to model of provide the inputs and print. So let us see if it works. So this is the example. So I will actually add it to the end. So now we have got three things we have written so far. The first one is this. We have defined inputs, weights, and bias. So inputs, we need not to define it here because we are using actually here. So that is why we say we can write it. So now we have defined weights and bias, which is very much required for this simple network. That is why we have defined here. So we ran this. So torch dot, we can say, see, instead of actually we can say for bias, torch dot. Okay, I think I by mistake I typed like this. It is tensor only. Run this. So now we have got weight as one tensor, bias as one tensor, and finally input as another tensor. So here you see I run this and then I run this class. So class is available. And then actually now I am giving this input and result is this. So run this. So now you see that neural network output is 1.5. And this sigmoid function you apply it, then actually it will become 1. That is different. But you see, this function what you have written, it is same as this. You see? You see? So now the question, see, don't think that whatever the whatever the things we are actually doing is not groundbreaking. It is same, but then why we have to use it? So okay, do you have? Can you think? Can you think? Can you tell me why we have to use this? Any guesses? Any guesses? So whatever you do, that can be done with a simple NumPy array. Okay, so basically, what happens is, I mean, you understand this. This is very important. So because once you are clear about basics, you can go to any extent. Okay. So why we need to use this is, first of all, we already discussed about it in the previous slide. One is this is what? Autograd. So automatic differentiation, you know what? PyTorch will keep track of all the operations you do. Okay, it will compute automatically gradients. Gradients it will calculate. So this is very, very important. So why it is important? Because the only thing, I mean, this is the same program we have written, but that is done in certain way that the whole thing is built on top of it, autograd. So without autograd, tensor is just another Python function. That's it. Okay. So everything, like for example here, see, for example here, what you have done here, neural network, and simple neural network, and actually you do init and you do forward. This will remember everything, and it will find out what got changed and what is the gradation. Actually, it will find out. So this is how the neural network will understand and learn. So this is what actually it has to be done. So okay, you got it right. So that is why this simple programs we still need to convert into a neural network. This is one reason. And one more reason is, see, whatever the numbers, recently, people were actually worried about this GPU unavailability. So you have understood, right? So GPU unavailability, the problem which, USA has put some, there are so many people are using AI. Why GPU we have to use? Because GPU is very, very, very important because it is very fast. In some calculation, a GPU can be several hundred or thousand times better than CPU for some calculations. Okay, you can understand why it is so. So you learn that. Okay, but that because of GPU, okay, Okay, so this torch, PyTorch can use GPU very well. So see, GPU, it will work, it will use it very well. Okay, this is why. Okay, and one technical thing. So there is something called CUDA. So this is actually, this support has to be there, and PyTorch version compared with CUDA support. And if you're using NVIDIA GPUs or GPUs, then this PyTorch will run very fast. Okay, will run very fast. This is one more reason why we need to use uh, you know uh, what why we need to use neural networks. And finally, there are other reasons that you have to integrate with neural network layers. There will be multiple layers. So if you write the program, one program is fine, but if you write multiple programs and if you want to integrate, it will be very easy. And it can be efficiency, memory tracking, all those things will be there. That is why we have to use the neural networks with PyTorch. So this will be easiest thing to do. So though the same program we have written earlier, we have not used PyTorch at all, still workable. But the thing is, if you have multiple neural networks, this cannot work because it will not remember. It will not use the GPU. It will not use it cannot integrate with different layers. So that is why we cannot use that. We have to use this neural network. Hope you have understood. So you have done this. I have given you one small example without torch neural network and with neural network torch. So you have understood, right? So whatever we have done is the input is raw material center. Then you do all the working and output is like we have got output of 1.5. Last 1.5 we got to. That sigmoid will be converted to 1. So this is what actually we have done it. So this is what is the output. And this is like a training and they will remember it. So in the next session, I will also show you how they will remember it. It's a very simple exercise you will be able to understand. Guys, I hope you understand this. So let me ask you if at all you understand completely about this. Okay, I got 3 and as expected. Good. So thank you for responding fast and you all have understood. Now we will actually understand one thing which is actually very, very important, which is the how decision is made in the neural network. What are the activation? They are called the activation functions. What are they? We will actually understand this. So take a break of 2 minutes. We will come back. So just think about it. Take a break. So that let your brain do not block. So take a break. We will start in 2 minutes. Guys, hope you're back. So let's actually look at activation functions, the key decision makers. So we will actually see what is activation functions. So we have seen the activation functions. These are the decision makers. Okay. So now activation functions are like traffic lights. So any information in our network, they will decide what gets through. Okay. So you can think that, like, pass through or stop it or modify it or anything you can do. These are the activation functions. So we will see how it works. Guys, give me 1 second. Okay. So this is like a traffic lights, or it can be like a specific when the light is passed through, it can be passed through a prism, or it can be through a red glass or green tinted glass, like that. So we will actually see what is that. So these are the popular activation functions. ReLU or Sigmoid or Tanh. You know Sigmoid. Sigmoid means squeeze everything between 0 and 1 to either 0 or 1. So this is squeeze. So this is Sigmoid. And Tanh, you know that, value of Tanh, it can squeeze between, it can be between -1 and 1. And this one actually keeps positive, ignores negative. Negative we don't want, only positive, and ignore the negative we don't want. This is what actually is this. And how it is used. First of all, we will see whether it is used, how it works. See, this is used mostly on the image recognition, and this is on the binary classification and Tanh and the software. So actually, when I was actually in the electronics lab, I was wondering why Sigmoid will be used. So we had a Sigmoid related something. It used to pass whether light is there or not. So it will become on or off. That switch was there. So it is yes or no, and same as Tanh is based on this Sigmoid, but it is actually yes or no, and this has a multi-class specification. Probability, for probability we will use it. So let us see all these 4 things in action. It should be easy for you to understand. So I'll go little bit fast. So here, okay, it is taking some time to open. So guys, you look at this. So we are using Torch, and you create a tensor. When you create a tensor, you can pass. See, this Torch nn, we have got ReLU, Sigma, Tanh, and all. What we will do, the input, we will pass it, and we will see what is that will get through. Okay. Here, what is that? Guys, you can hear me, right? Can you make some sound? Can you confirm if you can hear me? Because network is slow. I want to be sure you are listening to me.
You're audible, sir.
I see. So looks like this is actually not rendering. It is taking too slow. Okay, got it. So now what we are doing, we will do this. Actually, we can do even simpler thing. So let us actually run only this. We will actually run this and run this. So what we are trying to do is this. So this is the input. X is the input. The X input values are -2, -1, 0, 1, 2. Okay. Now we are creating the input, and we are first printing the input, and after that we are calling ReLU, Sigmoid, and Tanh. Okay, for various values, how these are executed, actually we will see. So this is the input. Now, as expected, ReLU will actually remove any value before less than 0 to 0. You see that 0, 0, 0, and all the positive values it has kept as it is. And Sigmoid, you see that you have got every value -2, -1, 0, 1, and 2. Everything between you it will try to compress into 0 and 1. Okay, it will start from 0, means the values are -2 to +2, no? So -2 is 0, 0, and actually, 2 is the final element. So now this is what actually it has done. And finally, we have got -1 to +1. So this is what actually distributed. So these are all the things. These are the things that actually you can. But why, how these are useful? Very useful, because ultimately you are playing with numbers. You have to add, you have to convert, you have to converge, diverge, and you convert in between 0 and 1. All these things you have to. Okay, so then only you will be able to make some sense. So hope you have understood all the 4 functions. Okay. Only let the good stuff through and not removes negatives and sigmoid and Tanh, right? And I hope you have understood this. Let me ask this poll. Next thing is we are actually trying to understand one more thing, which is nn module and nn sequential. There are 2 things here. So if you see the program, earlier program, we have got this, not here. Here, nn.Module we have. Okay. Now we are also doing one more thing, which is nn sequential. These are the 2 things. Actually, we will actually see how they work. So here, when we are building networks, right? How these are useful, we will see it. So first of all, nn.Module, it's a blueprint for all the PyTorch modules. And nn sequential, this is actually quick way to stack the layers in the order. So you have seen multiple layers, guys. Look at this. You have a layer, this layer, this layer, this layer. Like this, you can have multiple layers, and those kind of layers you can do using nn.Sequential. So either this or this. So you need to use both. Okay. So this is what actually you are actually working. So this is how all the professional, neural networks are built. Now, 2 ways to build the network. So we are actually, let me show you. This model is nn.Sequential, first one, and second one. This is actually like ReLU, then actually nn.Linear, it is a ReLU again, and nn.Linear 64 data. So these are the values it has. Okay. Now you see that this is method 1. This is how you can do it. Or you can do, first is layers. You create multiple layers. 1, 2, 3, 4, like that. So like how we have done this, same way we have created. So either you can create like this, or you can also create like this. Both are fine. And you can modify, both are powerful and flexible. So you can use any. So when you create a network like this using the nn.Module, in the init statement, in the init method, you call the super, that is anyway there. But here we will actually do self.layers is equal to nn.Sequential, and we will pass 1, 2, 3 like this. We can. Okay, so there is something called dropout also, ReLU also, all these things we are actually doing. And then finally, we will return self.layers of x. So all the layers, right? We provide the whatever the input, it will go through all the layers and it will. So now let's see the complete code here. Here you see that this is one method that we can do. Now the thing is, see, I think now let us actually this method we will actually execute. And guys, can you tell me how to execute this? So far you have understood. So how to execute this? Parender, can you tell me? So you're not at all responding. Parender, are you there? Okay, very simple. So here, first of all, you create a custom network. And we call model is equal to custom network, bracket open close. And you actually do one thing, you will pass some value, right? So here, there is something called rand function. Okay, we will actually use that. This is the input, or we will say this is the input we will give. Input is equal to torch dot rand bracket open 1 comma 784. Okay, some value we will give, and we will pass the we will call that we will create the model of input. We will provide this input and print the output. Okay, so now we will run this. Okay, no problem. Okay, now I think we have to execute this also. This and it is taking some time, so we will give 1 or 2 seconds. We are running this. Okay. Now we have got here, so we got the output as we have got this output as, so we have got the input as, first of all, we will also put in print the input and output. Print the input and output. So this is, you look at this. This is the input. Okay, so much is the input we have given. And for this input, we have got this output. Okay, so you know that something is happening, but you are not very sure about it. Don't worry. We will not, we will not do too much of a thinking right now, but what we have given, it is processed, and there are 4 steps here, and all the 4 steps, it has gone through, data has gone through the steps, and finally, we have given the output this much. So I hope you have understood this. And this is what is neural network. Okay. So I guess by now you know the semantics, and you know that you give some values and values are transferred, and those values are modified efficiently, and how they will remember, we will see it. So today have understood these many concepts. So what is deep learning? We have understood. PyTorch basics we have understood. Tensors and autograd. Why PyTorch is very important we discussed. And we also discussed PyTorch is very useful and how to build a simple neural network, activation functions, and then nn.Sequential, how we can do that, we have understood. Okay, so hope you have understood. Now we will actually do one more example later. So what I suggest is, so you try to understand what is the difference between TensorFlow, which is already established. What is the difference between TensorFlow and PyTorch? Okay, you understand. So industry usage, when to use which, and what is the ecosystem. All these things you try to learn, and in the hands-on time, you actually, there is something called a digit classifier. I think similar thing we already written in the machine learning. So you try to do the same thing here. Okay. So I hope you have understood. Now let us conclude it. I mean, this our hands-on task, please complete it. And we will actually start with the quiz. Guys, hope you are ready. And I will ask you questions now. Be ready. Okay. So now here is the first question. What is the main purpose of activation functions in neural network? So here are your options. To make networks faster, to introduce non-linearity, and to reduce the memory usage, or to prevent bugs. So what is that? Activation functions, ReLU and all, these are the thing. Okay, so the answer is to introduce the non-linearity. Why? Because there are a lot of functions. So, linear transformation is not enough, but we want to understand the complex patterns and do it. So these are all ReLU, Sigmoid, Tanh are at the non-linearity. So that is why we need this. So why not make networks faster? No, we are not looking at making networks faster. We have to make it work, because when it works non-linear, then only we will be able to modify and actually you will get the required values. And here is question number 2. I mean, this is how you responded. And now I'm going to the question number 2. In PyTorch, what does dot backward method do? So this backward method, we didn't do it, but guess it. So what does dot backward does? Reverses the network or calculates the gradients automatically, goes back by one epoch. Epoch means one time. Epoch. So this you need to know this. You will actually epoch meaning. So epoch means it is a period of time in the history. It can be 1 second, millisecond, or something like that. But epoch you will be hearing again and again. So you understand it is a period of time. That's it. So now we are coming back here. So now goes back by one epoch and undoes the last operation. What is that? Question number 2. Here are your options. Okay. So here is how you responded. And the right answer is calculates gradients automatically. Backward method means it will calculate trigger the PyTorch's autograd system. Autograd system, the gradients it will be calculated. Okay. So, and one thing you should remember is, see, when you create this one, when you create the here we have created, right? So when you create a tensor, so you can actually when you create a tensor, you have to say requires autograd. Require autograd. Where is this? So this is what actually you will provide. So when you declare like this, then what happens when the backward method is triggered? This autograd system compute the gradients of loss. What changes that are done to all the parameters that have requires a autograd is equal to requires grad is equal to true. So this is useful for training the neural networks. Okay, this is how it remembers each operation. It will remember it. Okay, good. So now you have understood this also. Now we will go to the next one. Now this classification we didn't do it. Actually, we didn't do it. Actually, this is actually the program we have. You are supposed to do it. Hands-on task, digit classifier. So handwritten digits 0 to 9, it is a classifier. We have done it in previously using the machine learning. Now the same thing we are doing it using this. So please do this, you will understand. So we have a 70,000 handwritten digits are there. So we will actually give this as a input. Okay. So 28 pixels into 28 pixels, 784 features are there. So that we are actually doing it. We have to convert into 10 classes, 0 to 9. Okay, good. So now please do it, and we will actually, if you don't finish it, tomorrow's class, I mean, in the next class, you also need to explain this project code and, show the results. Guys, that's about the neural network. I try to go very slow, the concepts. I hope I have explained well, but still, you may feel little bit not clear, but do some, reading and all. I will tell you, if you understand deep learning, you know what, you are the number one. So put more effort, and I promise you all the, project code, project, examples, tests, everything I will give you, so that you will be number one. So make sure you understand this code, and I will see you in the next class. If you have any questions, I'm available for a few more minutes.